A very good day to our operating system lecturer, Madam Sel. My name is Mohammad Zufayri bin Sulaiman. I'm from Group 6 of MC, where my group members are Nurfakhira Husna, Binti, Mohammad Salleh, Muhammad Hisyamuddin bin Muhammad Radzi, Syakirah Syasya bin Serudin, and Muhammad Eziedan bin Muhammad Danish. Today, we would like to present our four-process scheduling algorithm project.
Hello, my name is Mohammad Eziedan bin Muhammad Danish. My metric number is 72446 and I'm from group 6. Okay, for my part, I will be presenting first come, first serve. Characteristic of first come, first serve is it supports non-preemptive scheduling algorithm. Its job basically executed on a first come, first serve. It is easy to implement and use, but it has poor performance and have higher waiting time that can lead to starvation. Okay, this is for my code for first come first serve. All the calculation is done inside the function. I have three calculation. First is to calculate waiting time. Second is to calculate the turnaround time. And third is to calculate all the average time of all processes. And this is my output for my program. I have enlisted every job inside the job list. The average waiting time is high, and first come first serve is not an ideal technique for time sharing system because the because first come first serve because first come first serve is so simple that it is not very efficient for every system that people want to use. Okay, that's all from me. Thank you.
Assalamualaikum, my name is Nurfakhira Husna Binti Muhammad Salleh. My metric number is 72831. I am from group 6 and I will present my part, which is shortest job next scheduling algorithm. Firstly, I will briefly explain what shortest job next algorithm is about. Shortest job next is a non-preemptive algorithm in which the process having the smallest execution time is chosen for the next execution. Once the CPU cycle is allocated to the process holds it till it reaches a waiting state or terminated. When you first run the program will prompt the user to enter the number of jobs that need to be processed, which is 30, according to the data given. After that, the job list and total of burst time for each process that are already been summed up will be displayed. The user needs to input the burst time for each job in order to get data to calculate waiting time and turnaround time. The program will keep asking the user to key in the burst time for each job until it reaches job 30. Lastly, the program will display the waiting time and the turnaround time for each of the jobs. Total time taken between the submission of a program for execution and the return of the complete output to the user are known as turnaround time. Meanwhile, the waiting time, the program will compare the burst time between the first and third and the second one. If the first one is bigger than the second one, the job will swap since the shortest job needed the shortest burst time to execute. That's all from me. Thank you.
Assalamualaikum, my name is Syakirah Syasya and I will present my part, which is shortest remaining time. Shortest remaining time is the preemptive version of SJF scheduling. The execution of the process can be terminated after some amount of time. The short-term scheduler schedules the process between the list of available processes and the operating process. At the arrival of each process will the least remaining burst time. Once all the processes in the ready queue are available, there will be no preemption and the algorithm will act as SJF scheduling. When the procedure is eliminated from the operation and the next process is prepared, The context of the process is saved in the process control block. The next execution of this method requires entry to this PCB. The PCB is stand for the process control block. As you can see in this slide, this is some part of my shortest remaining time algorithm. This is the output from the algorithm. As you can see, first is about the processes. The second one is the burst time. Third one is waiting time, and the last one is turnaround time. The average of waiting time is 172 at 4.8, and average turnaround time is 1 at 555.5, and the number of interrupts occurred is 3.
Hello and good evening. My name is Mohammad Hisyamuddin bin Muhammad Radzi, metric number 72808, and I will present about round-robin scheduling algorithm. Round-robin is a CPU scheduling algorithm where each process is assigned a fixed time slot in a cyclic way. It is simple, easy to implement, and starvation-free, as all the processors get a fair share of CPU. Next, I will present about the coding of program. As you can see, this is the output for our coding. And next is the output of the program. This is from job 1 to job 9. Our process is from job 1 to job 30. Next is job 10 to job 24, and job 25 to job 30. So the average turnaround time from job 1 to job 30 is 40604. The average waiting time is 39949, and the number of context switching occur is 3885. This is all from job 1 to job 30, and that's all from me. Thank you.
So, as a conclusion, from what we can see from this bar chart, shortest job next has the shortest average turnaround time and average waiting time among all of the 4 algorithms. The average turnaround time is 18010 ms, and the average waiting time is 8022 ms. So by this, we can conclude that we recommend using this shortest job next SJN as the most suitable process scheduling algorithm, since the output shows the shortest time taken to complete a process. That is all from us. Thank you.